Do you understand why you are here?
No.
You're here to know, understand, and appreciate the great knowledge of James Garfield, who created his own proof for the Pythagorean theorem.
The cartoon character's gonna teach me? No, man. When is US president? So is it gonna be you? No, that guy.
James Garfield's proof of the Pythagorean theorem.
This proof starts with a normal right triangle. For this example, we'll be naming the sides side A, side B, and side C. What James Garfield did, he normally flipped and rotated this right triangle and made sure that the side B of the second triangle is aligned with side A of the first triangle. And remember, these two triangles were constructed to be congruent. Next step is to name the angle in between side B and side C of the first triangle, theta. We don't know the angle in between side A and side C of the first right triangle. So we must first know what the angle is. We know that the sum of all the angles of a right triangle is 180 degrees. So since we're given two of the three angles, we can make it like theta plus 90 degrees. We'll be naming this angle as x for now. So it's theta plus 90 degrees plus x is equal to 180 degrees. Because for all triangles, the sum of the angles is equal to 180 degrees. If we isolate x, we get 90 degrees minus theta. So we're gonna change x to 90 minus theta. Since we constructed the other triangle to be congruent, they have the same angles. So this will be, as you can see, this actually technically makes 180 degrees. So for now, we will name this angle question mark. So it's gonna be theta plus question mark plus 90 minus theta is equal to 180 degrees. If we isolate the question mark, we will get, 90 degrees. So we'll just change this to make sure that it's understood as 90 degrees. Now, we will be constructing a trapezoid. The first thing we need to know is, how do we find the area of a trapezoid? Well, there are a couple of ways. The first is, just think of it as a normal trapezoid and use the formula, which is the height of the trapezoid times the average of the upper base and the lower base. The second way, we use the area using its components. Whatever you use, you will end up with the same answer. So let's try if it was a normal trapezoid without its components. So for this example, the height is needed to find the area. So in this example, the height is a plus b. It will be a plus b times the average of the upper and bottom base. So it will be 1/2 a plus b. Then let's think now about what we use using its. Let's think now about the area using its components. This will be equal to, since there are two right triangles, we just have to solve for one of these triangles' area and multiply it by 2. So to get one triangle's area, one right triangle, you make it 1/2 times AB. Then you multiply it by 2 since there are two right triangles. We also multiply it by the big triangle, the one with two side C's. And to find this, it will be 1/2 C squared. Now if we simplify this, we will get 1/2 A plus B squared, and the 2 cancels out, so it's AB times 1/2 C squared, plus okay, then to make things simpler, let's multiply both sides by 2 to get rid of the fractions. So it will be A plus B quantity squared is equal to 2AB plus C squared. Now if we multiply A plus B times A plus B, we get A squared plus 2AB plus B squared is equal to 2AB plus C squared. So since there are 2 ABs on both sides, we can cancel that out. And we are left with A squared plus B squared is equal to C squared, the Pythagorean theorem.
That's it? You want more, man? No, please. Alright, you gotta go. Wait, Jill. Where's my seat? I don't know how to buy it. Faster, Jill. I'm gonna catch up. Wait, Jill. No? So the cartoon character's gonna teach me? No, man. It's when he's US president. So, is it you? No, that guy. Stop.